Great to see you here in a new video related to quality management. We've been talking about different elements about quality. Now I want to say something about production and tolerances. And it's very important to understand why we have to do certain things in process control. Now, when we look at the origin, we come in fact from a piecewise production model and we moved to an operations model. Now, what happened? Now, originally, productions were in fact done, or things were made by craftsmen. A craftsman was making a nice part, complete weapon or some furniture, and it was one person, typically one person doing this, or a small group of people making things piece by piece. Now, when let's say, the craftsmen were making those elements, and when they had to make, for example, a large set of tools or weapons, the basic example in operations management, and let's say the operations model was related to Eli Whitney, who was in fact selling weapons to the American army, and the way he did the construction made them a lot cheaper, but it was also that they were not made by one person anymore. One person was typically finishing the item, correcting everything, putting it together. So even when there were large quantities, they were made by craftsmen. Now, what you could have, in fact, you could find those, or you still can find those very nice different elements, very unique, and each item even may have the name of the person who made it on it. So these are really people who are making very nice things. Now, what is very important here, that is each item was basically unique. It is in a way attractive because it's a unique piece, but it's also very difficult to exchange pieces. So when you had a same set of rifles made for the army, every rifle was in a way unique, and the pieces were not interchangeable. This was, of course, a problem. And when you looked at Eli Whitman, who was changing the way of producing those weapons, and that's the way he won the contract, different people are working on that same rifle, and basically the different people had to receive parts from that were made by other people. So somebody was making one part of the rifle, he or she was specialized in that work, and they gave it to the other people. So basically, at the end, when all the pieces were made, they were just assembled. Now, when you look at what we are doing today, when you're looking at a car, we are basically assembling parts that have been made. Assembling an engine, well, all those parts are made by sometimes different factories, different machines, and they are brought together and they all have to fit together. Now, when we look at the custom and mass production, there are some elements which are in favor of custom produced items, but also in mass produced items. Now, when we look at the custom produced items, the people who are working on those items, they have to manage a lot more skills than just that one little skill for the job they are doing. I just look at the production or the assembly of cars by Ford Motor Company and other people doing this, other companies doing this. In order to be able to do the work by one person, that person had to be highly skilled. And people who are highly skilled are in fact more expensive than people who are in fact having limited skills. The custom produced items are all unique, and it's very difficult to change the parts. Right? You cannot exchange the parts. You may have to adjust them. You may have to, let's say, remake them. It depends on how the possibilities are. Typically, custom produced item also takes a lot more time to complete. It's more expensive, and the quality is not always so clear because there is no standard. Everybody is making their part, finishing their part, it is working, but what are the standards? There are no standards in this case. When we look at mass production, the work is basically done by specialized people within clearly defined limits. And when you have those specialized people, they have to be good in one thing, and basically the labor will be cheaper. You can measure the quality objectively, and you have finally interchangeable parts. You have standardization of maintenance and repair, and it's a lot faster to complete the work and a lot cheaper. Now, when we look at production, we also have to look at something else, because since different people are making the composing parts, we also have to look at what can be done. Now, when we produce something, we have limitations. We cannot produce exactly the same element over and over. We have to look at those different parts in a way that they should fit into the assembled parts. And we deal with that with tolerances. A machine has a certain precision to make parts within certain limitations. We call those tolerances. Now, once we have those tolerances and we have machines who can do that, we have to have the right machines to create the right parts, because those parts will only fit together when the tolerances, in fact, are respected. Otherwise, you cannot combine those different parts. For example, when you want to create an engine for a car, all those parts have to be made within specific tolerances. Or you have parts for watches, the same thing. If they don't comply with the tolerances, you cannot create a good finished product. Now, the tolerances mean that we have to create something between specific dimensions. There is a minimum and a maximum dimension, but there is also a desired dimension. And the desired dimension is in fact what we would love to have. That would be ideal to have that measure when we produce the part. But because of the limitations of the machinery, this is not possible. Now, the operators of those machines, they are trained to operate them in the best way, and the tools can be developed in order to create those parts within the tolerances. So everything can be set up, everything can be monitored. And once you have all those products, all those elements that you have produced within those tolerances, they should lead to a product that can be assembled. An important thing to consider when we are looking at processes and production is about tolerances. Now, when we create parts that have to be assembled, they have to comply with specific characteristics. They have to fit together, so they have to be produced within certain values, dimensions, minimum and maximum dimensions. For example, when you want to assemble some parts of an engine, those parts have to fit together even when they have been prepared with different processes. Now, when you want to have a good assembly line, those products have to be made within specific tolerances. And when you see engineering drawings, you will always see that there are tolerances given. Also, when you buy a thermometer, it is given what is the precision. So the tolerance is basically what is the precision of production for those items. A very important element there is that we have to guarantee that the parts are produced within those tolerances. Now, when we are making these items, we're using a process, and those processes are producing these parts one after the other. It is possible to verify every part. In some cases, this can be done, but in most cases, we are going to see how is the process working by taking samples, and we verify how these samples work. And when we are looking at the tolerances, when we're looking at the production, we see here in this table a production goal with a dimension of 250 millimeters plus minus 5 millimeters. So the plus minus 5 millimeters is the indication of the tolerance. The lower tolerance for this product is 250 millimeters, while the upper tolerance is 260 millimeters. Now, when we are going to produce this, we are going to verify what is the process doing. So we are measuring those parts, and we know from the statistics that when we take the averages of the sample averages distribution, that we find the average of the population. Basically, that should be the production goal. We call this X double bar. Now, in our drawing here, we see that X double bar doesn't coincide with the production goal. So it means we have to adjust something. But what's more important here is to look at the control limit. So when we look at all those averages, these have to be between the lower and the upper control limit. So basically all the parts, or the vast majority of the parts that are being produced, are clearly between those tolerances, and our process is working properly. The parts are being produced and are compliant with the production goals. Now we will see later in more advanced courses about quality that we can talk, or we already spoken about Six Sigma. Six Sigma means that we are having higher precisions for the production, so less variation. It means that we can create higher quality products to put them together to get even better assembled products. So basically what we're going to do, we have to see first of all that the lower control limit and the upper control limit are between the tolerances. That's very important, so that we are sure that the vast majority of the items that we produce are compliant with the production goals. Now we will look at that later when we look at control chart. Another thing I would like to discuss here is what I would call the Swiss watch dilemma. We all know about those high quality Swiss watches, and we always think about Swiss watches that they are expensive and they are high quality. Now, we already spoke about quality and grade. Quality is about how we comply with the demands, with the expectations of the customer. Grade is the cost, the price of the things that we buy. So when you would say a Swiss watch is very expensive, it means that is the grade. But on the other hand, we also expect a higher quality compared to other watches. I remember when Leica came out with their first digital camera. Leica is a very expensive brand, very high grade, also always renowned and considered to be a brand of high quality. Well, their first digital camera was not really of high quality. Of course, they changed over the years and they adjusted their production, but grade and quality don't always comply. Now, when we look at those Swiss watches, when we have all those expensive processes, that production, we create all those different parts and we assemble the watches. So basically, assume that we have 10 identical Swiss watches, all made according to the stringent quality measures implied by the company. And we would expect, or what do you expect when you put all those watches together? You put them on the same spot, they all start at the same time, and we come back after a specific time. Now, all the watches are kept in identical circumstances, so there are no relativity effects, no gravity effects, no things like that. You know, when we have one watch traveling very fast, the time will slow down. These are things about relativity theory, but all the watches are on the same place. What do you expect? What do you expect to see after 10 days? And let's assume that those watches keep on going for 10 days without any problems. We have something what we call the instrument error. Did you expect that those watches would show exactly the same time? Because they started exactly at the same time. We may assume, since they're high quality, that the time on all those watches would be the same. But there is something that happened here. Although every part of those watches has been produced within those stringent tolerances, they are basically all a little bit different. They're not exactly the same. And it would be very, very rare, very, let's say, low probability to have exactly two watches which are in fact showing exactly the same time. It is possible, but the probability is very low. Now, the fact that we combine all those little elements that are a little bit different, it means that the clockwork inside of the watch is also a little bit different, and it's working at a different pace, although it will be very small, but they are basically different. And the differences that we register here are called the instrument error, and it is different for each watch or instrument. For example, when I was teaching at the aviation school, we had, for example, altimeters, very expensive instruments, rather precise instruments, but every instrument had a small error. So basically, when you were reading from the altimeter, you first had to correct it with the instrument error. So you had to correct the reading because every altimeter was a little bit different. Now you may think we don't have this with electronic equipment. Well, that's not true, because electronic parts also are characterized by these differences, by these tolerances. So all the instruments we have, they're always a little bit different. Now, it is clear that when we look at expensive Swiss watches, and we don't look at Swiss watches which are expensive because they have a lot of diamonds and gold in them, but when we look at the clockwork mechanism, we expect, of course, that those differences will be rather small. And when they're rather small, okay, we can neglect them related to the usage. Now remember that people have been doing some tests sending clocks, very high precision clocks, into airplanes to measure the difference due to relativity. Those have to be extremely precise instruments in order to compare those. But just remember the fact that we are producing these parts, they all have a little bit different measurements, so all those parts are a little bit different. It's not a problem, it's what we call natural or common cause variation, and it is a part of anything we do, from any production, any measurement we do. We always have this common cause variation, and we should never try to remediate that. It's inherent to the system. Now that's what I wanted to talk to you about these tolerances. It is very important to understand how it works. Anyway, we produce them. We cannot produce the same items exactly 100%. So with the statistical process control, we are going to see that the production average is according to the average that I expect. And the second element is to see that the variation is limited enough to create high quality products, or products with the quality that we need. This is the end of this video, and in the next video we will look into the effects of deviation from the average and the standard deviation and what it does to our measurements. I'm looking forward to seeing you in our next video. Thank you and bye-bye.